Hey guys, I'm Logan Reynolds and I'm going to be teaching you, this is a tutorial video, on how to solve a very generic, typical economics derivative type question that you might see. It's got about 4 or 5 parts to it and it could seem overwhelming at first, but trust me, by the end of this video you will be able to solve it like a pro. So let's get to it. A coffee shop sells 500 mocha lattes a month at $4.75 each. A customer survey indicates that sales would increase by $125 per month for each $0.25 decrease in price. I think it's important to note that in this question, some parts you're going to have to know how to do a derivative, and if you don't know how, that's no problem, I'll explain it when I get there. Part A of the question asks us to determine the demand or price function. So how I like to start a question like this is I like to organize the information that's given to me into 2 separate lines and then square them off into my 2 different equations. I then like to make my let statements to just also keep those thoughts organized so then I can move on to actually solving the question. I then take the information from the first box and make my x equation. So it'll be x equals 500 plus 125n, n being the number of price increases as said in my let statement. The plus means because it's increasing. I then take my p and I make it 4.75 minus because they're decreasing, 0.25n. I then isolate for n and sub it into my second equation to find p of x, which is our price function. Moving on to part B, we need to determine the revenue and marginal revenue. This uses derivatives of 350 mocha lattes from monthly sales. As mentioned previously, this question involves marginal revenue, which means that we need to use derivatives. Yay! Okay, and if you don't know how to do it, no problem, I'm going to explain now. It's easy. Our first example here shows that f of x equals to 350x plus 400. So what you do here is you put that little tick to signify that it's the derivative. You take away any constants because they are not carried through in derivatives, and you take away also your x. So that derivative would just be 350. In our second example here, y equals 4x squared plus 5x minus 3. So what you do, again with the ticky thing, you take that 2 on the exponent of your variable and you bring it down to multiply that coefficient there, again taking out the constants, for a final answer of 8x plus 5. So moving on to how you actually solve this question, your r of x, which is your revenue function, equals to the x of your p of x, your price function. So you just put an x in front of your p of x function and you multiply that x in to get your revenue function. You then plug in 350 into the revenue function for a total of $1,767.05, and that is your revenue of 350 mocha lattes. After that, you have to find the derivative of your revenue, which is of your marginal revenue. So you do that by bringing down that 2 and multiplying that 0.002, taking away the x from the 5.75, all that jazz, the derivative dance, and then after that you plug in 350 into that equation for a revenue that is increasing at $4.35 a week. Part C of the question is more independent and doesn't rely on the information of the original question, so I'm not going to include that on the page anymore. And Part C wants us to find the marginal cost after providing us the equation of what C of x is, of producing 350 mocha lattes, again with the marginal derivatives. We need to use derivatives. In terms of solving this question, it's very similar to Part B in terms of you just find the derivative, plug in a number, and get your answer. So you just have to find the derivative of your C of x. So you bring down that 2, multiply the negative 0.005. Another way you can think about it is taking down that 1 from your x and going down an exponent, so it's 0, so it's just 3.5, the x is gone. 400 disappears. You plug in 350 into the equation once you've simplified, and you get an answer of 3.15, which shows that when the production is 350 mocha lattes per week, the marginal cost is 3.15. Part D branches off from some of the answers and methods used in Part C and asks us to find the actual cost of the 351st mocha latte. So the cost of producing the 351st mocha latte is actually just your C 351 minus your C 350. So just your cost function of 351 minus the cost function of C minus 350. And once you plug in numbers and you get your answer, you'll notice that there is quite the similarity between the marginal cost of the 350 mocha latte and the actual cost of the 351st mocha latte. So for large values of x, the marginal cost when producing x items is approximately equal to the cost of producing the just one more item. And last but not least, Part E asks us to determine the profit and marginal profit of the monthly sales of 350 mocha lattes. Very similar to Part B, we need to find our profit function and then find the marginal profit function and just plug in 350 to find what both of those equal to. So what our profit function equals is actually our revenue function minus our cost function. So you just put both of those equations in there, you simplify, you find your P of x, which is 2.25x minus 0.015x squared minus 400. You plug in 350 into that, and you get what your profit was equal to with 350 mocha lattes sold, which turns out to be $203.75. Then you have to find your marginal profit. So again, with the derivatives, you put that tick, signifies a derivative, take away your x, bring down that -2 and multiply your 0.015, plug in 350, and you get an answer of $1.20, which is your marginal profit of 350 mocha lattes per week. In terms of real-life application, you might see this type of question with the revenue, the profit, and the cost for small business owners who need to try and figure out where their deficits are, what they need to increase at. But in terms of just derivatives as a whole, microbiologists, for example, use derivatives to try and find info about their bacterial colonies, their growth rates and temperature and food sources, things that change and things that are really important to analyze in their kind of environment. They rely on derivatives and the information that they give to them on how to go about their studies on bacterial colonies. And that is how you solve a typical generic derivative economic problem. So there's about 5 parts to it. There is the profit function, the revenue function, the cost function, not in that order, and then along with the marginals, you learn how to derive pretty simple equations. I hope that I explained it through properly and efficiently enough. Thank you for watching my video, and I hope that you guys keep mathing, keep going strong with your maths, and I hope that this was a good basic lesson on how to do this type of derivative question. So, bye!